Welcome back. Let's talk about OXOacids and their acidic strength. Compounds in which non-metal is attached to at least one OH group and one oxo group, we call them OXOacids. However, if compounds do not contain an oxo group, then they are called hydroxoacids. For instance, in the case of sulfuric acid, perchloric acid, and nitric acid, all these contain an OH group and an oxo group, so they are all oxoacids. In contrast, in the case of hypochlorous acid, it does not contain an oxo group but only a hydroxo group, so it's called hydroxoacid. Now, these oxoacids are acidic in nature due to the presence of acidic proton, which is the proton present in the OH group. For example, sulfuric acid in solution releases H plus ion, and it is the H that is attached to oxygen in hydroxo group that has been released, and which is acidic in character, which gives acidic character to the oxoacid. The anion produced is known as an oxoanion. Now, the acidic strength of these oxoacids can be predicted by the same ruling as was talked about in OXOacids, for which the link has been placed in the description. The first factor that controls the acidic strength is the oxidation number of element. Higher the oxidation number, more is the acidic strength. For example, on comparing sulfuric acid with sulfurous acid, the oxidation number of sulfur in sulfuric acid is +6, while that in sulfurous acid it's +3. Obviously, sulfuric acid is more acidic than that of sulfurous acid. In the same way, on comparing nitric acid with nitrous acid, the oxidation number of nitrogen in nitric acid is +5 and that in nitrous acid is +3. Obviously, nitric acid is a stronger acid than that of nitrous acid. Similarly, among the oxoacids of chlorine, we have perchloric acid, chloric acid, chlorous acid, and hypochlorous acid. As the oxidation number of chlorine decreases, so is the acidic strength. Now, among the oxoacids of carbon, nitrogen, sulfur, and chlorine, as you see, the oxidation number increases from +4 to that of +7. Obviously, the acidic strength also increases. Point to be noted is, oxidation number method is a handy tool to identify the strength of oxoacids, but it may not always be applicable. The actual reason behind the higher acidic strength of an oxoacid is actually the stabilization of its oxoanion. For example, the negative charge on oxygen is in conjugation with doubly bonded oxygen, hence is involved in resonance to get stability. Now, as there are 3 doubly bonded oxygens in perchloric acid, so delocalization will be more, hence more will be the stabilization. This leads to higher acidic strength of perchloric acid. In the same way, the negative charge on oxygen can also be delocalized onto the doubly bonded oxygens in sulfuric acid. As there are 2 doubly bonded oxygens only, so the delocalization is lesser compared to that of perchloric acid, hence is relatively less acidic. In the third case, that is nitric acid, the delocalization is only on 1 doubly bonded oxygen, that's why it is less acidic. Now, in the case of carbonic acid, there is nevertheless the delocalization of negative charge onto the doubly bonded oxygen, but due to the presence of lone pair of electrons on hydroxide group, that can also involve into resonance, hence competing for the earlier delocalization. This competition leads to less stabilization of bicarbonate ion, thereby leading to lesser acidic strength of carbonic acid. The same competition you can question in bisulfate, but the lone pair on oxygen there can be delocalized onto the next doubly bonded oxygen and it won't interfere with the normal delocalization. Now, coming back to oxidation number method, and that method was successfully applicable for the oxoacids talked about earlier, but oxidation number method is inapplicable for the oxoacids of phosphorus. For example, we have phosphoric acid, phosphorus acid, and metaphosphorus acid. As the oxidation number decreases from +5 to that of +1, you expect the acidic strength to decrease, but actually it increases. So the reason behind this lies in the stabilization of oxoanion produced. As you see, the negative charge on oxygen in metaphosphorus acid can get delocalized onto the doubly bonded oxygen. In the case of phosphorus acid, the negative charge on oxygen can also be delocalized onto the doubly bonded oxygen, but because of the competition from a hydroxy lone pair, the acidic strength decreases. And in the case of phosphoric acid, there are two such hydroxides which can have competition with the normal delocalization, hence it decreases the acidic strength further. Now, if the oxidation number happens to be same, then more the non-metallic character, more will be the acidic strength. For example, on comparing perchloric acid with perbromic acid and periodic acid, as the oxidation number is same and down the group non-metallic character decreases, so is the acidic strength. In the same way, we have sulfuric acid and selenic acid. They have the same oxidation state of +6, but down the group again non-metallic character decreases, so is the acidic strength. I hope you understand this. If you like my videos, please do not hesitate to subscribe my channel. Thank you.